building architect was more concerned with the look of the building rather than some of the practical realities of it. One of them was the way in which the building was heated and air conditioned. And in the year 2000, they installed two 15-ton HVAC units for a relatively small percentage of the space. And then the additional space that wasn't heated by the traditional gas-fired HVAC systems were heated electrically. So the electric bill for the community was extraordinarily high on an annualized basis. And the two HVAC systems that were installed were basically overkill, which for all intents and purposes, caused them to overwork themselves. So their lifespan at the building was cut short. And about 5 years ago, one of the systems had the heat exchanger went on it, so the system had to be shut down. So the community had a very large decision to make. Now the community at Incarnation, as I said, is not a large community. We have maybe 145 or 50 families there, and so this kind of decision was a big decision that had to be made. Underlying the mission of the community, the main components or tenets of the work that goes on there has to do with the environment and climate change. That all decisions that are made within the community are considered, the environment is considered in whatever way. Small things such as we've gone completely LED lighting for the most part. The water bottles are not utilized. There's never any plastic utilized for catering and so on and so forth. So recycling is a big deal. Blue box is a big deal. Organic materials is a big deal. So this has all been part of who we are as a faith community and at the core of it. Sorry, I'm just having a technical difficulty here. I just want to go to the next slide if I can. There we are. So on this screen now, I hope you can see some of the decision factors that led us to make the choice around the geothermal. The first was strictly from an economics point of view, that could we support any solution financially? And there were a variety of options before us that we needed to consider. The second was, how much of a risk are we willing to take? And we needed to make a decision that was both dependable for us. It was not dependable for one of our large tenants and would not of course, bankrupt us. But we really needed to do a risk assessment, both from an economical point of view and from a technological point of view, in order to determine, how far could we stretch ourselves. The third extremely important decision had to do with a green decision to support sustainable energy and the environment. And frankly, at the beginning, this was the most, I think, difficult part of the discussion to really convince people to consider, because in order to go green and to consider a geothermal would necessitate much higher risk than we originally had considered participating in. And certainly from an economical point of view as well, economically it was much, much higher also. And the last decision was the longevity. And we had just come away from seeing that this new technology of the year 2000 that was put in only lasted about 16 years. And we were sort of back to the drawing board. So we really felt we needed to make a decision that would not get us back into the same position within a short period of time. So those were the key factors. One of the components of the discussion that went on was in regard to the risk assessment. was one in which we decided that the risk that we needed to take in regards to sustainable energy or a geothermal system paled in comparison that the risk we were facing as far as climate change was concerned by not doing anything at all. We really thought we had a responsibility to be leaders in our community, faith leaders, to be able to be an example of what possibly could be done. So that was one that we really needed to consider, that we needed to take a risk on behalf of our environment and climate change. So I think there are people in political office that we should show this cartoon to. I think it would go a long way in helping them understand that, no, it is not a hoax. And in fact, climate change is real, and we all know that. So this next graph I want to show you, and we'll get more detailed in the coming slides. But there were four particular considerations that we wanted to that we took into consideration. The first, the bar graph on the left at the bottom, it says patch. That would be taking the existing system that had broken down and fix it, patch it, repair it, and continue to operate with that going forward. The second bar graph from the left is replacing that HVAC system with another similar new gas-fired system and replacing everything that exists just as it had originally. The third and the fourth are the considerations for geothermal. The first one, it says Geo 80,000. That would be the cost assessment based us raising up to $80,000. And the last one would be a geothermal system with us raising $100,000 in capital to begin with, the rest being financed. Each of these is broken down into subsections. The first is the blue bar at the bottom of the left, the two left bars would be our gas consumption, our usage on a dollar basis, on an annualized basis. The darker brown would be the electrical bill. The gray in the middle would be the maintenance required on each of the systems from a dollar perspective. And the last would be the financing, the capital and financing costs of each of these different systems. As you can see, the gas would be negated by using geothermal. The electrical costs between the traditional, the geo, on both cases would be relatively similar. The maintenance on the patch system would be quite high, but the maintenance on the new HVAC, gas-fired, and the geo would be minimal. And of course, then the financing on the geo at both levels of financing at $80,000 and $100,000 would be the largest component of our capital outlay on an annualized basis. So I want to go to the next one where it breaks down a little bit in a little bit more detail. I'm not going to go through all of this, all the detail, but what I do want to highlight is a number on the left-hand side, 2/3 of the way down, that says total. So this would be our alternative number one, the patch and repair equipment ongoing. By just fixing the system that existed would have been an annualized cost of about $40,366. Sorry, I beg your pardon. It is $53,819 based on our natural gas usage, the contract, maintenance contract, the repairs necessary, and so on and so forth. The next alternative, number two, a new traditional HVAC system throughout, again, based on the natural gas usage, maintenance, HVAC repairs, financing costs. The total would cash outlay $50,315. Alternative number 3, the geothermal system. Now the total outlay of capital costs, gas would be negated. Our electricity would be about the same. Our maintenance would be minimized, but the financing cost would be significant. It would be a total cash outlay on an annualized basis of $49,000 based on an $80,000 capital, either grants or raising money through contributions. So you can see that the geothermal was on an annualized basis equal to or less than the other 2 alternatives. Now, this goes back to a number of years before we actually got around to putting the system in. And the estimates of the installation of the geothermal system was $316,000. And we assumed we would be raising around $100,000 of that $316,000. Mac will spend a few more minutes telling us about what it actually came out to, but let me just say that the end result at the end of the day costs us a little over $316,000 for the equipment, the geothermal. Over the course of the years, we ended up spending just under or just over $400,000 because there are additional capital improvements we decided to make going forward. One of the most important parts of the discussion over the course of the 5 years that it took to begin this discussion was to have a group of people, all people who had interests, who had some background in a variety of ways, be it financing or engineering, banking, environmental studies. We had a good group of individuals who helped us really do our homework. We had a number of people who
I can probably do that.
What I call them naysayers, or people who kept our feet to the fire to ensure we had done the research and we had done our due diligence in all aspects. One of the big questions had to do with technology.
Hello, Paul speaking.
And what kind of technology existed.
Good, Rita. How are you doing?
Out there.
Yeah.
Hang on one sec. Thank you. It had to do with the technology, and so there was it took us probably close to a 2-year process to find the companies and the people with the expertise to do the kind of job properly. We discovered that there were lots of people out there who said, oh yes, we could do the geothermal project, but the more we investigated them or got references or looked into it, we discovered that maybe they didn't have the kinds of expertise and technological abilities that we needed. So it took a great deal of time. One of the things I think was extraordinarily important is that we had to keep the communication lines open amongst ourselves as a committee and the rest of the community, that we had regular ongoing town hall meetings. We kept updating people on what we had learned and the direction we were going. We had people offering us different options along the way. And we moved as quickly as the slowest common denominator. And in some of the time, we felt that we weren't moving fast enough and we wanted to get on with it. But what we soon discovered was that as people pressed us and challenged us and questioned about the variety of ways that we were coming at this, it became more beneficial to us because the more we got pressed, the more we learned along the way, which had large influences on the decisions that were made. Mac, I think, might share with you some of those decisions that were made as we went forward. So what I'm going to do now is I'm going to hand it over to Mac Morrison, who's the technological expert who knows all about this, to help us more clearly understand why we thought this was the right way to go. So I'm going to hand it to Mac now.
And I'm just going to jump in quickly to remind everyone, please feel free to use the chat box to submit any questions you have.
Thank you very much, Michael. I'm flattered by the compliment. I'm not an expert, but we've learned a heck of a lot in this 5-year journey. When we finally got to the resolution of, yes, we wanted to go geothermal, we were faced with many, many technical options. The first option was to take a pretty well standard type of heating and air conditioning unit and source it by air source, which would make a lot of sense to people because you see your air conditioners with the external attachment and so on like that. One of the issues that comes up with that is your capability of being able to get enough heat in the winter out of the air source. And the more we discussed and looked at air source systems, the more we realized that because of our particular geographic location, we were at risk of not being able to provide enough heat during the winter years or winter months. And everyone said, well, you'll have to put in backup electrical systems or backup gas systems or backup whatever. And of course, we were wanting to get totally off the gas, so that one pretty well wiped out the air source. And we opted to go for water. And in water, we, although it was more expensive on the investment side, in our case, it cost us about $70,000 to put 6 holes into the ground, 650 feet deep, which gave us about 1.5 miles of piping and water source. The beauty of that system is it comes up with a very consistent temperature. We're just trying to bring up a picture here of the drilling rigs that we brought in. There we are. The drilling, and I'll name the company here, we got GeoSource from Caledonia, Ontario, to do our drilling for us, primarily because they were one of the very few companies in Ontario that had the capability of going to the depths we wanted. And in looking at the depth we wanted, we were trying to minimize the amount of ground space we were going to occupy within the church property. So we went with them. The whole issue came down to how much capacity we would have. Well, we ended up paying about $70,000 for the drilling, complete drilling and installation of the ground source water source into the building, just up to the face of the building. You have to keep in mind that this system will last 100 years, virtually without maintenance. And we get testimony or backup from Natural Resources Canada and the provincial government in Ontario that these systems are pretty well foolproof as long as they're done to code. So that was the decision point in going to water. The beauty of this system is you're taking water out of the ground, and in our system, it is really consistent. We're drawing water out of the ground, or it's a closed loop, I should say, so we're not taking water, we're just circulating water through the ground at about 52.5 degrees centigrade. That, so far, we've been on the system for 6 months. It hasn't varied more than 0.5 degree. So it is constant. The whole system relies on being able to extract either heat or cold from that water source. And in our case, we're extracting in between 4 and 5 degrees for heating purposes. We're just about to go into the cooling season, and I don't think it will be too different. We will be extracting that amount of cool. So we're exchanging water or circulating water through, putting it back into the earth, and it comes back into the building again after going through the 1.5 miles of piping at that constant 52.5 degrees. So the technology is working exactly as the engineers had said it would. the internal systems that we opted for, in our case, we went with Mitsubishi, and we ended up with two heat pumps. These are extremely sophisticated units. They're totally digital. They will give you the option of being able to heat or cool off exactly the same unit at any given time. So you're not having to say, well, we need cooling in this room or heating in that room. The system will determine that based on the way the thermostats are set up, and will provide either heating or cooling to whichever area the thermostat asks for. So it is a very, very complex, I think the biggest problem we had with it was trying to outguess the complexity and try and figure out how we can adjust thermostats on a daily basis or on a weekly basis or whatever is required. We were very quickly told by Mitsubishi that once we set up the system, we should just leave it and it will look after itself. And that's effectively the results that we've had. The pictures you're seeing on your TV screen, one of them is the heat pump is on there right now. And it's a very simple system, very simple in terms of what it's got. We're pumping water out of the system, out of the ground source into the heat pump. The heat pump is nothing really more than a rather good-sized compressor, the same type of unit you'd have in your refrigerator unit or in your air conditioning unit, except this gives us the option, these particular units gives us the option of extracting heat or extracting cold at the same time. And it will give us both options simultaneously. The piping and the communication from the actual heat pump to the distribution system within the church is on wall-mounted fan coil units, such as you see in the illustrated picture that's there. And these are totally automatic. They do everything but think for themselves. They react to the thermostats perfectly. You see a picture flashing on your screen of myself turning the switch on to start the system. And believe me, it was almost as simple as that, just by flicking the switch. The preamble to getting to flicking the switch was about 2 hours of testing on behalf of Mitsubishi, at which time they came in and certified our system, and they said, you're ready to go. We haven't not seen them since that, and I don't expect that we will see them for a few years again. That covers the technicalities. One thing that we ran into issues with was communications, because we set up with Mitsubishi on the heat pumps and the fan coil units, and we set up with Grundfos for the water circulation system. Now, the two units are supposed to be able to talk to each other. We found it difficult to get the two companies to relate to each other. So I think that's an important factor when you're looking at these things, is try and pick equipment that is that can work together between the heat pumps and the water circulation systems, because it will save a fair bit of money in the long term. The other aspect is finding an engineer that has a vision. And we were very fortunate to have an engineer come on board with us that really had a good understanding. He's been in the mechanical engineering practice for over 20 years, and most of that spent doing nothing but heating and cooling systems. And he fully understood what we were looking for. He had great vision in terms of putting all the components together to give us, number one, a visual inside the church appearance that did not obstruct the architect's original plans. And secondly, a system that was pretty well run on itself, because when, particularly in a situation such as we're in, where we have a lot of tenants using the space, in our case we have a daycare, uses about 40% of the space within the church on a daily basis, and then we have everyone else coming in the evenings to use space or whatever. We wanted to have a system that was pretty well foolproof and could be set up to program to provide a comfort level for everyone without them having to play around with thermostats. And that's exactly what we got. It's a very intuitive system. It works really well in terms of giving us all the things we want. As a matter of fact, we're still learning how good it is. And in terms of the energy consumptions, we were a little bit off the mark when we started, but it's falling right into the area where we had hoped to be, and we've reduced our overall electrical consumption by about 20% so far, and it looks like it will carry on at about that level consistently through the year. Our projections would show us that. So with that, I'm open to questions at this stage of the game, if we have some.
Okay, well, I think one of the questions I hear a lot about is, you know, can you explain a little bit more about how you got the naysayers to get on board with this? You said it was a 5-year journey, so that sounds like it was a little bit difficult to get people on board. Of course, finances also were a big reason for taking 5 years, but how do you convince people to do something so bold and so big?
It was a constant part of the process that we needed to listen to what the concerns were and to get the information that the people needed so that they were convinced and confident that we were making a completely informed, a rational and thoughtful decision. There were many times along the way where we were challenged and asked questions that we frankly couldn't answer or couldn't give them a really clearly informed decision. So we were then had to go away and to do our homework and to speak to whoever was necessary and to come back again. And it took a great, a long period of time. I mean, people were concerned about the most interesting things that we had never thought of. Like, for instance, on the screen right now is a picture of the actual pumps that the fan coil units that offer the heating or the cooling into the space. And people were very concerned about the piping that comes out of those and goes along a couple of beams. And they were really worried that in some manner they might inhibit or change the actual look of the space or create, an eyesore. And we really, at the time, couldn't give them a complete or informed decision that it wouldn't change anything. So we really needed to find out exactly what it would look like and bring it back to them. They thought there'd be holes punched in the ceiling or in the walls and those kinds of things, and we really weren't aware of what was going to look like. So that was a kind of one fairly significant thing we needed to help people understand. The other was, going back to the economics of it all, we really had had to consider the higher financial implications. So the difference from a purely dollar point of view, from a traditional HVAC gas-fired system to the geothermal, was an additional $120 or $110 or $120,000, right, Mac? So that was a big jump for a small community like ours. And as we began to have these discussions, more and more people got on board, and we began a campaign of raising the capital necessary. Initially, we had thought $100,000 would have been a stretch for us. We ultimately came up with $264,000 either contributed or pledged to the project. So at the end of the day, our financing costs are even less than we had originally anticipated. And asking people why it was so much easier to raise the money, it was because they felt that they had been heard and listened to, and they felt as though they had been part of the process all the way along. And that in of itself was a really key component to ensuring that most people really felt this was the way to go. One of the big challenges for us was having people understand that, without heating, air conditioning, you don't have a community. And there were times that people felt that the church doesn't necessarily need to meet in a particular building, that we could meet in other places, or we could gather in rented space. And that at the beginning they thought that we needed to consider that option, that we could be a faith community that met in a different kind of context. But ultimately, we ended up going the direction we went. I can say comfortably that most people continue to support it. You don't always have everybody on board all the time, but I can say happily that we didn't lose anybody in the community, based on this project itself. It was probably one of the riskiest and most challenging projects that that Incarnation has undertaken in the 20 odd years it's been in existence.
Okay, great. We do have a question. You mentioned National Resources Canada giving a vote of confidence regarding the 100-year life cycle. What particular role did they play?
Say it again.
So you mentioned National Resources Canada, and they gave you a vote of confidence regarding a 100-year cycle. What role did they play?
Well, when we started with this, we went into all the research, all the research that both the province of Ontario and the federal government had done in terms of geothermal systems. And the comparison between the air source and the water source was the big question, because the cost variables are quite significantly different. And to look at the water source, we got information from both the federal research people and the provincial research people that said the life cycle on this type of thing would be anywhere from 75 to 100 years maintenance free, was their estimate at the time. And that was really a significant thing for us. You've got to be quite long-sighted in terms if you want to go into this. And that was one of the issues that Michael was just bringing up, that with the naysayers, for example, the more we could talk to them about the longer term. The short term was you were going to be replacing standard HVAC units every 15 to 20 years, which is about the life cycle. This system is very, very few mechanical parts to it. It's a couple of water circulating pumps and 2 compressors and a couple of fans. And that's about all the components that make it up. All the rest of them are digital components, very much like a computer. And the life cycle on the maintenance on it was far longer than it would have been if we were to stay with any kind of conventional system. And so if you say, well, what's your payback? It's a hard one to give you a 2-day payback type of thing. But if you look at the long term, you very quickly start to get a payback. 17 years. If you look at the total cost of putting this system in versus replacing it, you're going to have to replace the old system in 17 years, for example. By the time you get to 17 years, you've completely paid for this system, and you're not going to be paying near the maintenance on an annual basis. We estimate the maintenance on this system to be nothing more than replacing fans for filters for at least the first 5 years. Thereafter, we'll be into probably about a $1,500 a year inspection cycle. Whereas in the past, we've been paying anywhere from $3,000 to $4,000 on annual maintenance just on our various heating systems.
Okay, so just to confirm, National Resources Canada only gave you a vote of confidence. They were not involved in any other way?
No.
Okay, no involvement. Okay. I have another question. You would have... Okay, so there's another question. Along the way, you would have learned I would have had a lot of lessons learned. So what are some of your best practices now that you've gone through this process?
Extraordinary patience is necessary. I think the big one for us was of moving as quickly as the slowest common denominator, meaning that you won't get everybody on board along the way, but you need to be really attentive to communication and sharing as much information as you can, as often as you can, and just giving updates along the way. That, for us, I think, was a really important part. And I think that doing your due diligence and just ensuring that you've got as much technical information as possible. When we first began, we got nothing but negative feedback about people's experiences with the geothermal systems, that they leak, that they're not as environmentally friendly as they say they are, they're not compatible, they're unreliable, and it went on and on. And as we began to investigate, we soon discovered that the technology has changed drastically over the last number of years, and that really assisted us. And we did talk to, as say, a large number of people with the expertise in this area for sure. Anything else, Mac, that we learned?
Well, the other thing is that one of the big problems we had with the original building as it was designed was the lack of air circulation in a lot of the facilities. And that was because if you're to try and heat electrically with those, in most buildings, you try and seal the building up and you don't get proper ventilation. And this was a bit of a problem with the daycare aspect. One of the things that was introduced to us was what we call ERVs, electronic recovery ventilators. And we ended up having 5 of these installed, which are constantly bringing fresh air into the building. And also, at the time they extract the old air, they recover either the heat or the cool that's already in the air. About between 60 and 80% of that energy is recycled back into the building. So it's a very efficient way of bringing air in, whereas you don't have, and it reduces your costs dramatically with this system because you don't have to bring the air up from a 0 temperature if you're drawing it in from outside, raw cold air or warm air. So that was a big note. But the whole technology of it is something that I think if you're going to get serious about this, you've got to have an engineer that is patient, will understand what you're looking for, and then you have to have 100% confidence in him that he will deliver what you want.
Thank you. Okay, we have one other question. What percentage of electricity is used to run this system?
In our case, I would guess that it's probably in the range of about 30%. Of our total electrical bill right now would be construed as being energy, heating, and that type of thing. That's a hard one to call because we've been going through a cycle. We're going through seasonal changes, of course, as we speak. But from the time we started the system, we've seen a constant decrease in the amount of power required. We're trying to get to a baseline, and we're not quite there yet. We're almost at the neutral season where we're not either heating or cooling. And we don't expect that the cooling costs, which used to be very high, because going into your summer, you're using a hell of a lot more electricity based on just air conditioning systems. On this system, it's a lot more efficient for air cooling than its hardest load is to heat. Believe it or not, it comes down to the point of where we're looking at a very minor upsweep in the electrical consumption during the winter to heat, and probably a very flat line through the summer period. So the 30% energy, if we were to shut everything else off in the church, we would be down to about 30% of our normal consumptions.
Okay, we have another question. Is there a central building automation system?
Yes, not a full system, but the heating and air conditioning is totally on its own. It is. We don't touch it. Once it's set up, we've got what they call master thermostats that only with a password can you change the program on it. And so people cannot go playing around with it or anything like that. We do not have it on a remote control.
I have a question, because this is something that I've been asked, and being relatively new to this kind of thing. Mac, what do you do when people complain it's either too hot or too cold?
I can go in and tickle the thermostats, but I don't want to do that. I think I can get them convinced that it will change. But in other words, if you look at the thermostat and it says it's 21 degrees, that's what it is. It's 21 degrees. Now, the fact that there's fresh air flowing will make you feel that it's either cooler or warmer or whatever. But be patient with it, because it knows that it needs the fresh air, or because again, these ERVs calculate how much air they need to flow through the system to keep the air at a certain freshness level. I guess it's a CO2 reading or something like that. That's a little bit beyond my own technical knowledge. But so the system looks after itself. It does not have to be babied, and it does not have to be changed. And we had a few hiccups at the beginning where people said, oh, it's too hot here or too cold there or whatever. And when we found out what was causing those, we were able to adjust them immediately and settle it down.
Okay, we have another question. It's a two-part question. What types of heat pumps did you use? And what are ground loop temperatures through the winter season? So first, what type of heat pumps did you use?
The heat pumps are Mitsubishi, and to give you the model number wouldn't be practical because there's so many model numbers, but they're a ground water source heat pump system is what Mitsubishi refers to them as. And as I say, there was a 14-ton, we run a 14 and an 8-ton, so we have a capacity of 22 tons versus the 30 tons that we had with the old systems plus the electrical systems. The second part of that question was?
So, what are ground loop temperatures through the winter season?
The ground loop temperatures are constant at 52.5 degrees. It doesn't matter what time of year. That's the water source system. I'm amazed that it's constant. I was told 3 years ago by the engineer that when all this was done, it would be 52.5 degrees. And damn it, that's exactly what they gave us.
Does anyone have any other questions? that they'd like to submit? I do have another question around the role that faith communities play in doing this. I mean, obviously you're coming from a faith community, and what role do you think they play in tackling these issues?
Well, as I said at the beginning, that the risk that we were taking pales in comparison to the risk of doing nothing would be to the environment. And I think as faith communities, we have an innate responsibility to be good stewards of creation. We are called as faith people of faith, to work in conjunction with our planet, with Mother Earth. We are part of this living organic creation of God. And that if we are not taking our responsibility seriously as being partners and leaders, then we are not living up to who we are as faith leaders in the community. It is part of what we are called to be and to do, and it really is going to be incumbent upon us going forward to take the risks in order to be the leaders in our neighborhoods, in our communities, as I said.
This is a nice question that I think each of you should answer, give your own answer. The question is, what is it about the system that gives you the greatest satisfaction?
Well, I'll start off by saying, when Mac first hit the switch and a number of days later, two things. Number one was, after 5 years, it was done, and that we had succeeded and it was a wonderful feeling of accomplishment, that we had done something that we set out to do collectively. Number one. And number two, it felt as though the building was breathing. It was an extraordinary feeling. You could hear the hum of the system, and you could feel the change in the internal atmosphere of the building. It really felt as though the building was breathing again, and and certainly everybody that utilizes the space noted a significant change, significant difference, particularly in the areas that had no air circulation to begin with.
I find, from a personal point of view, I'm still weaning myself off the idea that I have to be concerned about the heating and air conditioning system. It takes a little while to get the confidence, but I've been watching the system, not quite daily, and I'm backing away from it slowly to hopefully be looking at it on a weekly basis maybe, and then saying forget about it because it looks after itself. I've been watching the electrical consumptions on the system on a daily basis, and I'm satisfied now that we're getting what we asked for and what we hope to get in that respect. And it's just a case of confidence. Our tenants are the same way. They didn't trust it at first because the old systems sure weren't trustworthy. They're getting to the point now where they're totally comfortable with the atmosphere that we're presenting them with in the church. We have had virtually no complaints in the last 2 months of variations in temperatures and so on like that. So it's a great comfort to us to be able to say, well, here, that's a system that's working, and it should be pretty well carefree other than cleaning filters or changing filters for the first number of years.
Okay. Thank you. So thank you everyone for attending the webinar. I think that's it for questions. And a very special thank you to Michael Patterson and Morrison for your time and willingness to share your experiences and best practices. The webinar has been recorded, as I mentioned, and we will email each of you a link to the webinar, and please feel free to share that with anyone you'd like. And this concludes the webinar. Thank you everyone for attending, and have a great day.